Now we get to Chapter 5, Models of the Atom. It's important that we understand what the model looks like and how we view the atom, especially when it comes to electrons and how electrons act, since electrons are basically what chemistry is all about. So the first real model of the atom was something like J.J. Thomson's plum pudding model, and scientists knew that now that there were electrons that were negatively charged and positive protons, but they didn't realize how they were structured. They believed that somehow they were just kind of all mixed in together. But as research went on, the next phase was the planetary model, where they realized that the nucleus was positively charged, and outside of the nucleus were electrons. So this would be a nitrogen atom, the view of a nitrogen atom, as we can see, with 7 protons, and there would be 7 electrons around it. But that's all that scientists really realized, or they believed. Now, Rutherford came along and he had a new model that the electrons, as we can see here, here's an electron, here's an electron, here's an electron. The electrons were going around the nucleus in orbits, and in different orbits. And this wasn't entirely correct either. Now the next model is the Bohr model, and this is the model that most people are familiar with. When they think of drawing an atom, they think of the Bohr model. Now the Bohr model is a big improvement because it explains more of the chemistry that goes on. The Rutherford or the planetary model doesn't really it can't really explain the chemistry. Now with energy levels, such as in the Bohr model, we can look at why chemistry happens, why things react, which we'll get to later on. So here the Bohr model, he proposed that electrons are found in the circular paths or orbits, also called energy levels. So these are energy levels, and they're specific distances around the atom, or the nucleus I should say. And they're fixed distances, and this will explain some of the chemistry. This is not a complete picture of the atom, but it's the one that we'll really refer to when we're looking at energy levels and bonding. Now in a little bit, in the next section, we'll get more specific. So let's first try and draw these atoms and see how it lines up. Protons, electrons, and neutrons. This is nitrogen. It has 7 atomic number and 14 atomic mass. So that means protons 7, electrons 7, and neutrons 7. And we can see in here we have 7 protons and we have 7 neutrons. Now the electrons, we don't just put 7 electrons randomly around the nucleus. The first energy level here can only fit 2 electrons. That's at most it can fit. Only 2 electrons will fit in that first energy level. Once 2 electrons are in there, an electron will go to the next energy level. So this energy level has 1, 2, 3, 4, 5 for nitrogen. Now the second energy level can fit up to 8. This has 5. So energy levels, if we have the nucleus here, the first energy level will fit 2 electrons. The second will fit 8. The third will fit 8 electrons. When we get into sublevels, we'll actually see that it's 18 in the third level, but for the Bohr model, we're going to just say 8. The Bohr model really only would work correctly up to level 3, or atomic, I should say, to calcium, atomic number 20. But for our purposes right now, we're going to say this. But as we'll see, the third energy level actually contains 18, and it goes on from there. So let's try and draw some of these Bohr models. And again, the Bohr model is just really good just for basic understanding of bonding and structure. let's look at an atom. Let's try helium. Helium is 4, 2. So it has 2, 2, 2. So we draw 2 protons in the middle. Now, if you want, you can do plus, plus, and then 2 neutrons in the middle, like neutron, neutron. But it can get very tedious. So it's fine if you just do numbers. I just do numbers because that's what you want to see anyway. We don't really want to, we don't care about seeing all of these pluses. We really care about seeing the numbers. Now the next energy level has 2 electrons. And again, if you want, you can do 2 electrons like that. I just do in one place 2 electrons. And a lot of people do it that way. It's just easier to see. Let's try lithium. Lithium is atomic number 3 and 4 neutrons, atomic mass 7. So in the middle we have 2 protons. I'm sorry, 3 protons and 4 neutrons. And in the first energy level we have only 2 electrons. It's all that fits in the first energy level. Then the next energy level we have 1 electron. So that lone electron is all there, all alone. No one to hang out with. It's kind of sad. Okay, so let's try fluorine. You guys should try this as well. I'll try and pause it and see if you get the same structure as I get. So protons would be 9, electrons 9, neutrons 10. So in the middle we have 9 protons, 10 neutrons. The first energy level will have 2 electrons always. The next energy level we have the remainder of the electrons would be 7 electrons. Right? So we have 9 electrons total, 9 protons and 10 neutrons. How about sodium? Sodium atomic number 11, atomic mass 23, has 11 protons, 11 electrons and 12 neutrons. So in the nucleus we have 11 protons, 12 neutrons. First energy level will have 2 electrons. Second energy level. Now another shortcut you can do is just draw a half circle. In fact, I'll show you the half circle as well. So we can just do half of it. So we have 11 protons, 12 neutrons. First energy level is 2 electrons. Second energy level fills up with 8 electrons. So there's 10 total electrons here, but remember we have 11, so the next energy level has that lone electron. And there we have sodium with a total of 11 electrons, 11 protons, and 12 neutrons. Okay, let's try phosphorus. Phosphorus is 15 and 31. See if you can get this correct. 15, 15, 16. So we have 15 protons, 16 neutrons. First energy level we have 2 electrons. That fills up there. Next energy level fills up at 8 electrons. And how many do we have left? We have 5 electrons. So in this one we'll have 5 electrons over here. So 15 total electrons. So this would be phosphorus. And again, if you want to do the whole circle, that's fine, to show all the orbits. Now we're going to start to get into the quantum mechanical model. And before we do that, we need to really know what a quantum is. Quantum is the energy required to move an electron from one energy level to another energy level. So for instance, from this energy level or this energy level to a higher energy level. So that takes an amount of energy to move that electron, to excite that electron, and that's a quantum. Now the amount of energy that an electron will require to move to another energy level is not always going to be the same the higher energy levels are going to be closer together, and thus it doesn't take as much energy to get from one energy level to the next. So an example they give in your book on page 129 is ladders. See, normally you have rungs of ladders like this, they're equally spaced, and it will take you the same amount of energy to climb up each step. Okay, it still takes the same energy from one step to the next. But in energy levels in an atom, the higher you go, the closer they are together. For climbing this ladder over here, it's going to take much more energy at the lower ends to go from one end to the next, as opposed to up here where their energy levels are very close together. It's the same thing with an electron in an atom. So it's going to take more energy to go up these lower energy levels than energy to go from one of these levels to the next. Now what we're going to look at is a redefined Bohr model, which will get into sub-levels or suborbitals. And you can see up here, there's these little numbers, 1s2, 2s2, 2p3. That's what we're going to talk about next. And this is basically saying there's two sublevels in the second energy level. And you can see that here. So if we look closely, in the first energy level we have 2, 1, 2. In the second energy level we'll have 2 as well, but then in the next one we'll have 1, 2, 3. Now we're not going to have to draw Bohr models like this because it gets a little bulky, but just know that we will split up energy levels 2 and up. So we're going to talk about that next, because the original Bohr model did not explain some certain things. Before we get into electron sublevels, we really need to now look at a even further progression of the model of the atom. Now with the Bohr model or the Rutherford atom, we had the nucleus here, and then we had objects such as the electron rotating or orbiting around the nucleus. But this is more of a large-scale view. It's not something that an electron would do. It's not just going to go around in a big circle like a merry-go-round. We look at a new model, the electron cloud model. Now, here's the nucleus here, and this cloud, this big fuzzy thing here, represents where electrons are likely to be found. So it's not as though they're just rotating around in a circle here. The electrons can be anywhere in this region. So, and they've mathematically shown that the electrons are anywhere around here, just buzzing around, moving extremely quickly. So somewhere around here is the electrons. The darker the color would be more likely that the electrons would be there. So in the darker regions has a higher probability of the electrons being there as opposed to the lighter regions. So the electron cloud model is really the model that is much more accurate. And we'll still use the Bohr model to help us with bondings and such as ionic and covalent bonding. It really is a nice way to explain things. But we have a more specific model, and that's a region of clouds where that electron might be. So an example of that, if we think about a propeller, we have basically 2 points here. But once that propeller starts moving, we don't exactly know where it is. It's somewhere here. That propeller, those propeller blades are somewhere here. But they are moving so quickly we see this basic cloud here. It's the same thing with electrons. They're moving around, they're buzzing around so quickly that this is anywhere they could be.